Now we'll discuss about a very important device, that is the cyclotron. Cyclotron. Okay, cyclotron is a device which was devised by Lorentz in 1932, and it is used for accelerating the positive charge particles. Remember students, only positive charge particle, not the negative. So it accelerates the positive charge particles like the protons and neutrons, etc. Okay, now first of all see what is its construction. This is a device has two D's, D1 and D2. Okay, D, A, B, C, D. Okay, D shapes. Okay, it is the hollow inside like this. It is the hollow from inside. Clear? And you should remember some specific values used in construction, that is a very high potential difference is applied, AC potential difference is applied across these two Ds, and it is approx 10 to power 5 volts, and the frequency of the applied voltage, it is 10 to 15 megahertz, 10 to hertz, million or mega cycle per second, and we apply a very strong magnetic field, that is and it is perpendicular also. Remember students, it is the perpendicular magnetic field, and it is of the order of 1.6 Tesla. You will think that 1.6 is not enough, but not student, because in our daily life, and we feel, or suppose I'm sitting here this time in Lucknow, so the magnetic field, the horizontal component of magnetic field here in Lucknow, it is only 0.3536 Gauss. Okay, Gauss is 10,000 weaker than the Tesla. Okay, it is a CGS unit of the magnetic field, very small, and in comparison of that, the Tesla is a very strong, very big unit, and 1.6 is much a very strong magnetic field applied perpendicularly. And one more thing, the pressure inside the D's, because these D's are empty from inside, so the pressure is very small, that is almost vacuum, you can say. It is of the order of 10 to power minus 6 millimeter of the mercury. Why we keep a very low pressure inside? Because when pressure is not low, in that case the particles of the air can damage or can produce the problem in the path of the moving charged particles, because charged particles which are moving with the kinetic energy, and that kinetic energy may be wasted, may be absorbed by these air particles present in the D's. So that's why we take the vacuum, almost vacuum, or a very low pressure, that is the 10 to power minus 6 millimeter of the mercury. So dear students, this is about the construction. Now see how it works. When at the center of this, we have a source of the positive charge ion. Okay, so because it is the AC supply, so when it comes out, suppose at that time it is the negative, in that case it will, you can say, it will be attracted towards the negative region, and it covers a circular path. Why? Because the magnetic field is here perpendicular, and just in the previous video we had discussed, when a charged particle enters perpendicularly in a magnetic field, where the magnetic field is perpendicular to the direction of motion of the charged particle, then the charged particles start moving on a circular path. So it covers a semicircular path, and when it comes in towards the second D, in that case it is the negative. It was the negative, na? So after every half cycle, the polarity of the AC is changed. So now it will become the negative. Initially it was positive, so it will be the negative. So in this way it is negative, so positive charge particle will be attracted, and then it will become negative. So in this way the positive charge particle will start moving on a circular path like this, and in every cycle its speed will increase. And it will achieve greater kinetic energy, and the radius of the circular path will be given by R is equal to mv upon qb, and the time to complete one cycle, it is the pi r upon v. Okay, or it is pi m upon qb. Dear students, if you watch the previous video, you can see the time period was 2 pi m upon qb, and here we are taking only the half. Clear? So, and here you can see also the time period and the frequency also does not depend on the speed of the ion and of the radius of the circle. Okay, in this formula you can't see the radius and the speed, and reason is clear, because R and V are self-adjusted. Frequency or the time period both depends only on a ratio, charge to mass ratio. You can say the Q upon M. Only it depends on this ratio, Q upon M. Okay, Q upon M. Only it depends on this. Clear? Q upon M only. So in this way it start moving, and every cycle it gains the more speed, more kinetic energy. Okay, now see one more thing, that is the achievement of resonance condition. What is the resonance condition in this apparatus, in this device? Actually when the frequency in resonance condition, the frequency of the applied voltage and the frequency of the moving charge particle should be same. Only then it will work properly. So we can say the resonant frequency should be equal to the applied frequency. Okay, but we know frequency is given by 1 upon 2t, that is the qb upon 2 pi m. So therefore we can say the resonant frequency should be equal to the q by qb upon 2 pi m. It should be the resonant frequency in this condition. One more thing important about the cyclotron. What is the limitation of the cyclotron? What is the limitation? There is some limitation. The limitation is that it cannot be accelerate the particle to velocities as high as compared to the velocity of the light. What is the reason? You can see the reason from this formula. M is equal to m naught under root 1 minus v square upon c square. M naught is the mass of the rest mass of the charged particle. M is the mass of the charged particle when it is in motion. Okay, so if we increase the v, the mass will also increase. Okay, so what is the reason? The mass m of the particle increases with the increasing of the velocity. Okay, so mass m increases with the velocity of the charged particle. So that's why we can't accelerate the particle to velocities as high as comparable to the velocity of light. We can't. Okay, Remember students, one more very important information about the cyclotron is that since the mass of the charged particle, mass of the electron, you can see the mass of the electron is very less, very less in comparison to the mass of the proton or the mass of the deuteron, etc. Okay, because proton, deuteron, etc. Are heavier particle in comparison of the electron. So electron will get more and more velocity in every cycle, and it will not get in this process the sufficient kinetic energy. Okay, sufficient kinetic energy. So it will get out of step with the potential difference. So that's why remember cyclotron, due to its very less mass, is not successful in accelerating electrons. Okay, so kinetic energy, more kinetic energy means the more number of cycles, more number of circles it should form, and kinetic and the electron will get it very fast. Okay, it will not get the sufficient kinetic energy, but the proton, deuteron, etc. will take some time and they will be accelerated much more in comparison of the electron in a by moving on a more circles. Okay, so in this way, in every circle it gets the more energy, and there is a provision of the deflector here. Okay, we have a deflector here which deflect the positive charge particle to go outside, okay, to deflect from its path. And this more accelerated charge particle will come out from the cyclotron, which can be used for different purposes in physics. Okay, so this is about the cyclotron. Thank you, friends.